In our project, we're trying to design a virtual assistant that helps users by guiding them on how to operate an automatic external defibrillator or AED machine. And the AED machine is a device that helps saving people's lives, and as such, it is typically used in high-stress scenarios. And what ends up happening is that even though the instructions of this machine are somewhat simple, users still make lots and lots of mistakes. And some of the most common mistakes include selecting the right pad. There are specific pads for adults and for children. Another common mistake is the peeling off of the instructions of the pad. Unfortunately, people forget lots of times to just do this very simple operation of peeling off the instructions. And then, probably the most problematic issue is the correct placement of the pads on the right location of the body. So inexperienced users make mistakes on these steps all the time. So our idea was to create a virtual assistant that would guide the user by breaking down the whole task in a number of easy to follow steps. And the idea was to use the camera of a Google Glass or of a phone to have their camera and with computer vision algorithms to detect if the step was correctly performed, and if not, to have some sort of corrective feedback.
So I'll cover the architecture and the task flow of our solution. So in terms of architecture, we realized initially that we are dealing with an incredibly hard problem. That problem was to detect the chest and the torso of a human body. So it's very difficult for a machine to identify that. There have been a lot of solutions for the face and the arms, but for the chest and for the torso, we couldn't find many solutions out in the literature. So we realized that we'll have to use deep learning, and we also had to make sure that it was real time. The user was getting feedback in real time. So to enable deep learning in real time, we had to use a concept of a cloudlet, which is basically a server next to you, which can perform state-of-the-art deep learning algorithms and computer vision algorithms on there with super low latency. So our architecture is we are running a client on Google Glass or an Android phone, which connects with a cloudlet. On the cloudlet, we perform all the computer vision and deep learning computations. And from the cloudlet, we ping third-party APIs like the Microsoft Face API to get the age of the person. I'll cover more on that. So starting from a solution, how does a solution work? The first step is the user starts the client on the glass or on the phone. As soon as he starts the client, we load the deep learning models onto the cloudlet so that the models are in place. They'll only have to, do the computations. So that really helps us in terms of speed. Next step is the user points to the subject's face. We ask the user to point the camera to the subject's face. And from there, we detect the face, and we also detect the age of the subject. So using Microsoft's Face API, it gives us the approximate age of the subject. So using that, we come to know, okay, the subject is an adult or the subject is a child. So we know which pads to pick in the next state. So in the next state, we go on to the pad detection state, wherein we have different pads. So these are the adult pads, and these are the child pads. So whenever the user is an adult, we ask the user to kind of show this in front of the camera. And our deep learning based algorithms, they have been trained to detect this pad. So they detect this pad, we do color segmentation on it to detect, okay, the pad is red in color and not blue. So that helps us validate that the user has picked up the right pad. After that, we move on to the peeling off problem, wherein the user forgets to peel off the pads. So there, we ask the user to peel off the pads, and the peel off pads basically have these AR tags on them. So we detect this AR tag on the pads, which shows, okay, this has been peeled off now. Once that step is complete, we move on to the final step, which is detecting the positioning of the pads, whether the positioning of the pads is correct or not. So we take those pads, the user puts it on the subject's body, and we ask the user to point on the torso and the face of the dummy. So again, using state-of-the-art deep learning algorithms, we are able to detect the joints of the subject. So we get the shoulder joints, the hip joints, the elbow joints, and from there we are able to have a skeleton of the subject. And from here, we detect that, okay, the pad is placed here, so it means it's in the correct location. If it's placed here, it's not in the correct position. So the system will system will throw an error. And everywhere, all across this, we are using a voice-based system so that the user knows what is to be done. He's constantly instructed using the voice medium. So he knows what is to be done. Even feedback is given to him, corrective feedback.
And I will talk about the lesson we learned through this process and our future work. The first thing we learned is we can ensure the robustness of our system by using the speech interface as a fallback strategy. Because as you can see here, our Google Glass is connected to the cloudlet. What if this internet connection is disconnected or the cloudlet crashed? Our system will still work. It's just we will miss all those computer vision techniques, but we will just using the conversational interface to ask the user whether the pad is red or blue, or whether the patient is adult or child. This way, we can still help the user even if the internet is disconnected. Second, we learned that the state-of-the-art deep learning techniques can give us near real-time output using a cloudlet. Because the idea of the cloudlet is it runs at the edge of the internet, so it has low latency to the Google Glass. And because all our computer vision algorithms are highly efficient, so we can process all of them in very quickly, and we can give the feedback to the client in real time. Because operating AED machine is a very time-critical task, so having a low latency is very important here. The third lesson we learned is we can increase the accuracy of the recognition by combining multiple computer vision algorithms together. For example, in this step, we first use T-pod object detector, which is a deep neural network model, to get a bounding box for this pad. Then we use a very simple classic CV algorithm, color segmentation, to detect whether it's a red pad or blue pad. By combining those two models together, we can very accurately detect the pad. And as for the future work, one of the first things we want to do is we want to improve all the computer vision algorithms. So we want to provide more training data so they will be improved and they can work from different view angles and in different lighting conditions. Second, we want to do a formal empirical evaluation for our system so we can know how accurate it is, what's the performance, as well as how usable it is for our targeted users. Third, we want to also explore the use of other sensors, like the depth camera, to improve the performance of our system. Next, we'll have a live demo showing how our system works. Here the phone is connected to a server, and the phone now asks the user to show the face of the patient. And now the phone detects the subject as an adult using the Microsoft Face API. And now it asks the user to show him the pad. Now you can see that's an incorrect pad. The blue pad is for child. So now the phone asks the user to show the right pad, which is a red pad. And then the user peels off the pad and shows the AR tag on the pad. Now the phone detects the AR pad and asks the user to place the pad on the patient. Now the phone detects the pulse of the patient as long as a pad, and it detects it's at the correct location. Now you can see the user place the second pad at the wrong location. And the phone just tells the user the pad is at the wrong location. He needs to put the pad on the left torso. And that's the right location of the pad. Here you can see now it detects the pad is at the right location, and it tells the user now the user can operate the AED machine to deliver the shock.